Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT training everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus. And this episode is Troubleshooting Network Connections, and you can do that with me, but mostly with Don Pizzette. Don, good to see you.
Hey, glad to be back. And in this episode, in most episodes, we learn about a new technology and we see how it works when everything works right. But we're going to do something different in this episode. We're going to talk about when things don't work right, which sadly is all too often. So when you run into a network issue, you got to be able to troubleshoot it. In this episode, we're going to take a look at several commands and utilities that can help us to troubleshoot and isolate a problem, to figure out where the issue is, and then hopefully be able to resolve and get that corrected, or at least figure out who to blame and push it off on them. So that's what's coming up right here in this episode.
Where do you start when troubleshooting network connectivity?
All right. So for me, I have a process that I follow that, you're welcome to change or emulate or whatever. Everybody kind of does things differently. But for me, the first time I notice a network issue, I immediately want to establish a scope. I need to figure out how much of the network is affected. So for example, let's pretend for a moment that I fire up my computer one day, I open up a web browser and I type in www.google.com and I get server not found. Okay, well, Google has a ton of money and the odds of their servers being offline is pretty low. So the problem is likely somewhere else, but I don't know, maybe Google's offline. Who knows? Maybe they finally ticked off the government enough and they got shut down. We need to figure out where the problem is. The problem could be at Google. It could be Google's internet service provider. It could be the internet backbones. It could be our internet service provider. It could be our firewall, our router, my machine, my network interface, my operating system. These are all different pieces of that puzzle, and any one of them can be broken. I don't want to waste time troubleshooting all of them, though. I want to quickly identify where the breakdown happens. And there's a couple of tools that really help us to do that, all right? One is ping. Ping is a very old utility that lets us send out an echo request, and then the other side will do an echo reply. They'll send a message back, just establishing connectivity. If I try and ping Google and I can't get through, that's a pretty good indicator of a problem. And in fact, ping can actually help me check DNS at the same time. Let me show you what I mean. If I go to a terminal, and I'll run on this Google example, right? So I'm going to ping www.google.com. Well, the first thing ping is going to do is do a name lookup. It's got to convert that name to an IP. If it can't do that, then I can't get to Google. And that tells me I've got a DNS problem.
Oh.
If it does turn it into an IP, then it's going to start sending pings. And if that fails, that tells me I've got a network issue. So we can quickly differentiate between the two. And when I do that ping, I can see right here, the very first line, it converted it from a name to an IP. And if you do this on your computer, you'll get a different IP because Google does geo-routing. So you're routed to an endpoint near you. So you'll get a different IP, but I do see that it converted it over. All right. Now, I'm using IPv4. If you're troubleshooting with IPv6, all the tools I use this episode are actually, they have IPv6 variations. With ping, it's super easy. You just take that ping command and you stick a 6 on it. And so now it's going to do the IPv6 one. I actually don't have a functional IPv6 address on my laptop. So I get network is unreachable. Right? Which tells me I don't have a way to get to that network. That either means my default gateway is down or I don't have a valid IPv6 address, which is exactly what I've got here. So, but if you're testing with IPv6, just stick a 6 on the word ping. Right? Now, if I ping Google, I know I'm good. I know I can get to the system.
Mm-hmm.
I was able to do a name lookup. I can send traffic all the way over there. So I may have some more advanced problem. But if I can't ping Google, then there's something wrong in between here and there, and I need to figure that out. And there's two utilities that are really handy for this. There's an old utility and a new utility. The old utility is traceroute. Traceroute's been around a long time, but a lot of distros are not packaging traceroute anymore. So don't be surprised if this command is not installed. If it isn't, you can install it by using your package manager. It's available in all the repositories out there. But you can run traceroute followed by a name like www.google.com. And what it's going to do is map out all the routers in between you and Google. So the first entry that I see right here is our router right here in the building. So that's ours that's on the other side of that wall over there. And the second one, I see GRU, that's Gainesville Regional Utilities. That's our ISP, right? That's their router. And then we start moving across the internet through backbones and so on before we get up to Atlanta, where apparently we drop off on Google's system right there. If I were to see a stop in this, right? So if all of a sudden, like line 5 was just a bunch of asterisks, that tells me right there that's where my problem is. I wasn't able to get past that point. Now, if it's downstream, you know the network issue is not your fault. But if it's right there at the beginning, then you know it is your fault. It's your problem. The first hop is your router. The second hop is your ISP, typically. I mean, on an enterprise network, you might actually pass through more of your own routers. They're normally easy to spot that way, though, because they have private IPs. But your ISP, your link to the internet might be down. And so you can call them and file in a support ticket. But if it's beyond that, then it's beyond your control. It's up to these other ISPs, to the backbones, to Google. But at least you've identified it, and you know not to waste your time troubleshooting your own computer. The problem is somewhere else, right? But right from here, I can tell if it's the very first hop, then it's likely a problem with my computer, the switches that I pass through, or my router. If it's the second hop, then the problem is either with my router or my WAN connection to the ISP or the ISP, right? And then everything after that is out of our control. So it's a great way to kind of establish where to look, where to focus and fix things. So let's say that very first one failed. I know it's my computer or my link to the router. So I can then take ping, and instead of pinging all the way to Google, I can try and ping my router. So for example, here on my network, I know my IP address is 10.0.10.224. That's my address. And if I do an IP route, my default route is 10.0.0.1. So can I ping 10.0.0.1? If I can get to my router. And if I'm not able to get to Google, then something's going on beyond that, right? But the problem's not on my laptop or not on the switch between me and the router. If I can't get to the router, I've either got a problem on my laptop or on the switch in between me and the router, right? In this case, I can get to my router just fine. So next, I would ping my own IP address. Now, the reason I'm pinging my own IP address, oops, let me do an IP ADDR and get my address again. The reason I would ping my own address is because I need to test whether my network adapter is working properly. And when you ping your own address, it's actually generating a message that passes through the network adapter driver, hits the adapter, and then returns back. So I can figure out whether that's working. If this doesn't work, either I've assigned the wrong IP to myself, or I've got a problem with my network driver. I can also ping the loopback, but the loopback is different. The loopback won't engage your network driver. So if you ping 127.0.0.1, it takes the driver out of the mix, and now you're really just testing your TCP/IP stack. So if I just want to see if the software stack is working properly, I can ping the loopback. So each one of these helps me to establish that scope, to figure out where that problem is. I got on a tangent here and forgot. I mentioned traceroute was the old tool, and then I never mentioned the new tool. The new tool is called tracepath. Tracepath is a little bit different. If I point that at www.google.com, tracepath is installed on most systems by default, and you'll see it looks very, very similar, but it is a little bit more advanced. Oh, actually, I had a break right there. So with tracepath, it got cut off. What happens here is a lot of times there'll be a firewall or some other rule that can stop you from being able to communicate across, and it looks like I hit my ISP and got stopped right there. Most ISPs allow traceroute because it's been around a long time. Tracepath is newer, and not all of them do, so apparently I'm not being allowed. But I do see that I hit my own router here in the building, and then I hit GRU before I dropped off. So the problem is off of my network. I would know to call them and blame them. So those are some of the tools we can use to kind of establish the path or establish the scope. And just remember all the things that I did there: ping, traceroute, and tracepath. You just stick a number 6 on the end of them, and now it's IPv6.
So Don, where do we go if the problem is on our end?
All right, if the problem is on our end, it could be a physical problem. Those are the easiest, right? Check your cable. Are you plugged in, right? And sadly, I've forgotten to plug a cable in before. Or, cables come loose. That happens. And those are the easy ones to troubleshoot.
Especially if you have a cat.
Yeah. Get chewed through. Rabbits do that too.
Yeah.
But assuming that everything's physically hooked up the way that it's supposed to be, we need to take a look at our configurations, right? In the previous episode, we had a chance to look at network configurations. We saw where in Red Hat-based operating systems like CentOS and Fedora, it's going to be stored in /etc/sysconfig/network-scripts. In Ubuntu or Debian-based systems, it's going to be inside of /etc/network or possibly /etc/netplan, depending on what system you're using. But those are ones that you'll want to jump over and take a look at. There are a few other ancillary files I think that we also mentioned in the last episode. Let me just show you here. If I go into /etc, there's a handful of other files you want to examine. For example, if I wasn't able to do a DNS lookup, then I've probably got an issue with my DNS server, right? So I want to test the DNS server. How do I know it's working or not working or whatever? Well, I use the NS lookup utility quite a bit. NS lookup lets you do a name lookup. And if you do www.google.com, it's going to use whatever DNS server you're configured for, which we can find inside of /etc/resolve.conf. This file right here stores who our DNS server is, right? But if I go and do a lookup and it fails, I might want to just real quick try a different DNS server, right? Just to try. Cloudflare has a DNS server at 1.1.1.1, really easy to remember. So I could do an NS lookup for Google, and if I stick on the end of that 1.1.1.1 like that, that's going to tell it to do a lookup against that other server. It's kind of like getting a second opinion, okay? I can't do a name lookup off my default. Let me try somebody else. And if my default is failing and this other one works, then I've got an issue with my DNS server, right? And either I need to fix the DNS server or I could switch over to this other one and go that route. So you have different options there. But it lets you get a second opinion. There's also another utility called Dig, and Dig does a slightly more in-depth name lookup. It shows you a little bit more of the conversation that happens. If I do dig, www.google.com, instead of just returning the address, it actually returns the actual bind format result. This is how it would be configured on the server. So you get a little bit more information. And if there's an error, you'll get more details in here about what the error was. So if I think there's a problem on DNS on the server side, I'll usually switch over to the Dig utility because it gives you better information. You can even put it in a verbose mode and you actually see all the data that's being sent between you and the DNS server all right in there. All right. So DNS, couple of different places. The configuration, you definitely want to look in /etc/resolve.conf and check your servers right there. Make sure they're set properly, fix them if need be. Remember that DNS can be overridden in the /etc/hosts file. So if a name's not looking up, it could be that somebody's been messing around with your computer, or maybe you did and forgot. So for example, I wouldn't be able to get to IT Pro TV right now because my host file has IT Pro TV mapped to 1.1.1.1. So I would need to remove or comment out that line in order to get to the site. Because otherwise, if I try and ping itpro.tv right now, it's going to succeed because there is a real life 1.1.1.1, but that's not the actual server. So I've definitely got a mix there that's going to cause a problem. We also have various other tools if we just want to quickly see our configuration and make sure that it's right. For example, IP-ADDR, which I've already run, just to show me the addresses that I've got on my system and all my link details. If I just want the link details, you could run IP-Link. I never do this because I always want the IP address. But if you do IP-Link, you'll see the MAC addresses if you're trying to troubleshoot layer 2, just to see if an interface is up or something of that nature. And then there's good old IP route to see who that default route is. Again, I've used all three commands in this episode already. They're pretty prevalent as far as just checking your configuration to make sure that it's right.
What if our settings don't match the running configuration, Don?
That happens, right? So, maybe I'm looking in resolve.conf and I see a couple of DNS servers, but then when I do an NS lookup, it's defaulting to some other server, right? A lot of times it indicates that we've edited the configuration, but that it hasn't taken effect yet. And you could reboot, or you could just restart your networking stack. And that's pretty easy. On a system that uses systemd, you just say systemctl restart network, right? And that's going to restart that stack. Actually, I would need to sudo that to do it. And that'll restart. That'll reread all of the network configurations and get them put back in place. The exception would be if you were running like a netplan system, then you would need to say sudo netplan apply there. And that would apply the changes. Actually, if you do the systemctl one, that'll work on a netplan system as well. But when you do netplan apply, it actually doesn't shut the system down first, or the service. So it's faster to do netplan apply. So that's the better way to put those in. But just look to those, restart that service, and then you should see those changes go in. If the changes still don't go in, then there's likely a typo or an error that's preventing it from being loaded in. So go and double check. Look for a stray period or comma or something like that that's causing a problem.
Can we see if traffic is actually coming in and out? We do that?
Yeah, actually looking at the raw traffic can be really handy. I'm a network engineer by trade, so I've looked at tons of data over the years just passing across the network. The more you learn about it, the more you can interpret and determine what's working and what isn't. But even from a casual perspective, you don't have to be an expert to look at the raw data crossing a network and figure out whether things are working or not. Uh, One real handy utility that we can use, and I know we used in an earlier episode, is the SS utility, right? To pull up socket statistics so we can see sessions and other things that are being built across our network. In the other episode, I think I just used SS-AN, which shows all sessions and shows them by number instead of name, so it doesn't do DNS lookups. But there's several different variations we can do. So for example, one of the popular ones is ATP, which says I want to see all the sessions and I just want to see TCP. I don't want to see UDP. UDP doesn't really create a session anyway, so there's not a whole lot of point in seeing it. And when you run that, you'll see the ones that are in place that are actively listening. The P just means that I want to see the ones that are actively listening. So I see that I've got several different services that are running on my laptop. Like I'm running SMTP for one reason or another, and SSH and so on. But most of them are bound to my loopback address, which means only I can get to them. So I say I'm running SMTP, but I'm the only one who can get to it. Meanwhile, things like SSH and RPC have a star by them, right? So anybody should be able to connect to my laptop using SSH. They'd still have to authenticate, but they should be able to connect. Thing here is that you can see that they're listening and you can see if there's any peers. I know that nobody's actually connected. If somebody was connected, I would see them here in this session. You can do SS-TP to see any active connection, even ones that have gone the other direction. If I was going out, would show up in here. I don't have anything right now, so it's all kind of empty. There's SS-route, which shows the routing table. Whoops. Oh, actually, it might not do it in this version. In some, you can do SS-route to pull the routing table. On CentOS, we would just use the IP route command to pull it up, so that's not going to work for me. And on some, you even have SS-program. Let's see if this one works for me. Whoops. Program. Nothing. Which is supposed to show me the programs that have ports that are held open. And, it would help if I opened some programs to hold some ports open. So let's do that. Let me get a few things open here. Let me do the Star Wars thing that I brought up in the other episodes. We'll get
Which is
that fired
always
up.
fun.
I know. And we'll pull up a web page. Maybe we'll go to centos.org. So I've got a web page open. There we go. Now I should have something better in here. And that is still just bringing up the help. So do I not have support for that tag in here? If you look at the help documentation, you'll see there's a number of different things that you can pull up.
Right.
And being able to identify the programs that are holding ports open is really handy. I know we can pull it up by process, but the program tag is nice because you actually see the program names, and apparently it's not supported in this version. Let me see if it is in my Ubuntu. This is another challenge we have, is that there's a standard set of tools, but different distros run different versions.
Right.
And so you may find where the version on yours doesn't have support for something that another one does. So as I look here on Ubuntu, let's see if we have that dash process. And I'm not seeing dash program here either. I'd have to dig through it and see. But here, we'll switch to process and see that one. There. And so I get a list of all these processes. So I see Firefox right here. And I can see the sessions that it has open. Here's HTTP, HTTPS. My VMware tools have a session open right now. Maybe it's checking for updates. Wow, Firefox has a lot of sessions that are open.
Goodness.
But as you browse through here, you'll see all those different sessions that you've got in place. And somewhere in here, I'll have that Telnet session that I opened in the background. It's quite a bit. You'll probably need to combine this with grep to really, actually get the information that you're looking for. So, if I grepped for stuff on port 23, I guess I should have done like a :23. I might need to escape that out. But anyhow, we can see those processes and find the information and just kind of look at the high level, like the metadata, right? I know the source, I know the destination, I know the protocol. I'm not really seeing the raw data. If I want to see the raw data, like if I want to see the actual packets that are crossing the network, there's a really cool utility called TCP dump. Now, I'll tell you, in real life, I actually use another program that's not on the exam called Wireshark. Wireshark is a protocol analyzer and network sniffer, and you can run it, and it will capture the packets on the network and give you a graphical table that you can expand out and see all the traffic, and it'll even convert a lot of it into a human readable format. So Wireshark is really cool. You can see it at wireshark.org. But we can do it from the command line also, and that's important because if you're troubleshooting a server, you're probably SSH'd in, you don't have a GUI, it's a remote server. So how do you see the raw data crossing the network? And the utility I want to show you is TCP dump. TCP dump will interface with the TCP IP stack, and any packet that passes through, it'll grab it. Now, by default, it won't grab the payload, but it will grab all the other information, the source, the destination, the headers, all of the, if you know the OSI model, the 7 layers, it's basically getting everything except for the application data itself. And it can drop it into a file, which you can turn around and open in Wireshark. Wireshark will read it just fine and show it all in a nice, easy to read format. So with TCP dump, whoops, let me change that here. I'm going to start catching all sorts of stuff. I'm going to run TCP dump, and I'm going to sudo it to make sure that it's got full access to the adapter. And then I'm going to tell it which adapter I want to capture. So I'll do a -I to tell it the interface, and I'm going to capture ENS33. That's my adapter name. And then instead of displaying it on screen, because that's not too handy, I'm going to drop that into a folder. Oh, I just realized I'm in my ETC folder, so I need to get out of that. Let me get into my home directory. There we go. And now I can redo this. Let me do sudo TCP dump -I ENS33. And I'm going to use the greater than symbol to take the output of that command and drop it into data.txt. So just going to dump it into a file. All right. So that's now running. It's capturing the data from that adapter, and it's dropping it into that file. Now, let me go to another tab. Oh, actually, that's my Star Wars tab. I don't want to lose that one.
There you go.
So let me go to another tab. Here we go. And if I take a look at that data.txt file, there it is. I can see it's at 312K of data right now. And if I just kind of keep watching, now it's 376K. It's growing because it's watching that data. And if I were to tail that file, I'm using tail because the file is being actively written to, so I don't want to like open it in an editor. That'll cause all sorts of problems. But when I go to view it, here I can see the network data passing across the line. And see how it's scrolling? This is just me with a telnet session open.
Goodness.
Imagine if I was streaming video. This would be overwhelmed with the packets that are going across. This is just simple telnet. I'm also seeing things like broadcasts on my network and other things. So let me break out of that. And this time, or here, I can just scroll back up. And we can see a lot of stuff that's going on. Like here's an ARP request for somebody trying to find the default gateway. That's not me, it's another machine. They're having to send out a broadcast to find it. I'll see unicast in here that are from that telnet server, from the blinking lights. We could cat that file. And so if I cat, whoops, data.txt and pipe that into grep and look for the IP of blinking lights, which I don't know offhand. I might be able to look for like telnets. There we go. And here I can see the telnet sessions and the data that's being passed in between me and them. So quite a bit kind of showing up in there. And there's filters you can use with TCP dump to only capture what you want. But the neat part about this is I can let it run for a few minutes, and then I can just hit Control-C to stop it. And when it stops, I can take that data.txt file, and I can load that in Wireshark or some other protocol analyzer, and it can lay it all out nice and neat for me to see in a graphical interface. Or I can just come in and use less and open up that data file, and I can come through here and just scroll through and look. I'll do a forward search for telnet. Whoops, if I spell it right, that'll work better. There we go. So now I can find the telnet data, and I can see right here, towel.blinkenlights.nl. There's that connection that I opened up earlier, and you'll see that passing through. You can also do command line arguments to get the raw data of the packet, but oftentimes that raw data can be really big. You don't normally want it, so that's why it doesn't capture that by default. But you can change it to be a true packet capture where it gets the payload as well.
Don, is there anything that we can do if we think, a firewall's blocking us?
Yeah, so I showed ping as a way to test connectivity, and it's truly a connectivity test. It just makes sure that you can get there. It doesn't test the software, right? So the fact that I can ping, let me get out of this. The fact that I can ping www.google.com, that doesn't actually mean that I can get to the web page. I might be able to get to the server and then the web server is stopped. Now, again, for Google, that's really unlikely, right? But if I'm running my own web server, maybe I crashed the web service. I shut down Apache to do an update and forgot to turn it back on. So I can ping the server, but I can't pull up the web page. So in those scenarios, we can test with the actual client. Like I could fire up a web browser and connect, but we don't see a whole lot. So there are some other utilities that are really handy for actually testing a protocol. And one of the famous ones is Netcat. The cat utility I've been using to view files. Netcat lets you view network connections. It's probably installed on your system by default, but if it isn't, you can just install it real quick by doing a sudo yum install or a sudo apt install nc. It's usually just called nc, or your package file might be called ncat. This one's actually nmap-ncat. The people who make ncat also make the nmap utility, which is a port scanner that you can use on a network. So, but I want to use netcat, which is nc. And so I could come in and I could do something like, I can ping itpro.tv right now. Okay, I can ping it, but it's mapped to the wrong IP, but I might not know that, right? So then if I try and browse to it, if I fire up Firefox and I try and go to itpro.tv, I get an error, all right? I could ping the server, but I can't get there. And that's because it's pointed to the wrong IP, and the server it's pointed at is not a web server. It's a DNS server. So when I try and connect on port 80, I get nothing. I could verify that by going to the command prompt and using netcat and pointing at itpro.tv and trying to connect on a port, right? If I try and connect on port 80, that's where the web server should be. And when I run that, it should just sit here and disconnect. Or I might actually get an error message with something that means something. But if it just sits here and times out, that's telling me it can't get there. I could test other protocols. There might be a firewall that's blocking port 80, but allowing port 443. So then I could break out of that, which I'm just hitting Control-C to break. And then I'll do 443 and see if I get anything better. I don't get anything. I could try 53 and connect. And each time, it's just sitting there. It's not actually connecting to that system. All right. So this could indicate that a firewall is stopping us from actually connecting. All right. If I were to fix that entry, so let me remove the host entry that's overriding that. There. So we'll just get rid of that. All right. And so now if I ping itpro.tv, there we go. Now I'm actually getting our real IP, right? And so now I could try and do like an NC, point to itpro.tv on port 80. And this time it should connect. It's just sitting there. If it's just sitting there, it could actually be connected, in which case it's expecting me to send commands. So I could send like a get command. Yeah, there we go. So I sent a get command, and it's actually trying to return the web page. Well, this is an unsecure connection. So when you connect to our server, it just redirects you to the secure one. So that's what I'm seeing here. But I'm actually able to talk to the HTTP process on that server. So I know I'm not being blocked by a firewall. I'm able to communicate. So I might have a problem with my web browser. Maybe I got a bad proxy or something like that. But when I connect here, I'm able to see it. Kind of makes me want to connect to that original server and see if it got anything. But you can connect on different ports. So if I want to connect to like 4.2.2.1, which is a DNS server on port 53, I can connect. And then I can issue commands against it if I know the commands to issue. And that's the tricky part. Every protocol uses different commands. I knew with HTTP to use a get, or if you connect to a mail server, you can use HELO to initiate a session. It's a hello command with one L. But I don't know the DNS commands to enter to do a name lookup and submit those. The dig utility would show me. But if I try and send things to it, I'm probably just going to get an error like that. So it's a neat utility to be able to connect. And then the other thing is that when you establish a connection, you should at least have a connection up. So the netstat utility or the SS utility can show you those connections, and you should see that it's up. And if you're not getting anything, then it's probably an issue on the other side. So those are all different ways that we can look to try and rule out whether or not we're being blocked by a firewall.
Great stuff as usual, Don. Thank you very much. Troubleshooting network connections. Another wonderful episode instead of CompTIA Linux Plus. And, I have a feeling that there's something else you want to say.
I really don't.
Wow.
It was a lot.
That's great.
It was a lot of tools. There's more. There's tons of more tools. We actually have in our library a show that is just all network troubleshooting tools. As far as the exam, those are the main ones that are out there. There's no right or wrong in these. You pick whatever tool you want. Some people like to troubleshoot from the outside in, from the inside out. But at the end of the day, there's no right or wrong answer. You just hope to find where the problem is as quickly as possible.
I knew if we fished long enough, we get a fish there. Troubleshooting network connections, again, inside of the CompTIA Linux Plus series. Make sure you watch every episode. You're going to be very glad that you did, especially when that exam comes rolling around. Do extra studying, take notes, and take advantage of the supplementary information inside of our course library. You're going to be very glad you did. Check it out. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.